everyone, I'm Brandy, an OpenSciEd teacher and professional learning facilitator. Welcome to OpenSciEd Chemistry Unit 1, Lesson 10. This is an important lesson where our students will be investigating temperature change as liquids mix, as well as collecting data from an online simulation. Let's take a look at how we got here. So during lesson 9, we figured out that density of a substance is its mass per unit volume. Changes in energy and matter happen together, including in convection when energy transfers as substances move. So in this lesson, we're wondering, how can we measure the energy transfer a berm prevents? Here's the lesson at a glance. This 3-day lesson is where students will be investigating temperature change as liquids mix, as well as collecting data from an online simulation. The video is embedded in the slide deck for you to show your students how to use the NetLogo simulation. There are 4 big parts in this lesson. Let's see what happens in each. In the first loop, we plan and conduct an investigation for liquid-liquid energy transfer interactions. After we collect and share our data, we have a building understandings discussion where the students propose initial explanations for their findings. We figure out qualitative ideas regarding equilibrium. In other words, energy transfer between 2 objects or samples, initially at different temperatures, will cause both to reach the same final temperature. We also figure out the factors that influence the final temperature of the water are the masses and the temperature differences. We wonder how we could actually predict or quantify the final temperature of the water mixtures at equilibrium. So in the second loop at the beginning of day 2, we build a mathematical model that we'll use to predict the temperature changes, and we build on the idea of energy conservation using areas graphs. We figure out energy is conserved and it flows between the objects, but it's not created or destroyed. And we wonder how energy is transferring, and that could help us to see what is happening with particles or with energy. Next, for the third loop, the students will carry out an investigation with an online simulation. We figure out that conduction is the transfer of energy through direct contact as the particles collide. And this supports our idea that the mass times the temperature change represents how much energy is flowing. Scientists call flow through conduction heat, and they represent it with the letter Q. We're wondering if we can multiply the mass times the temperature change to show the energy transfer to melt a glacier. Then in the fourth loop, which stretches across the end of day 2 and all of day 3, we plan and carry out yet another investigation, but this one is an updated simulation. And we figure out that the specific heat of a substance or a mixture tells us how much energy in calories is needed to change 1 gram of it by 1 degree Celsius. We have an equation to calculate the heat transfer to a glacier from warm water, but we may not have the information we need to apply this equation to the context of the Ilulissat Glacier. So, what did we figure out? Well, overall, we figured out that energy transfers between objects at different temperatures until thermal equilibrium is reached, with the final temperature depending on each sample's mass and initial temperature, whilst conserving energy. Heat is transferred by conduction through direct particle collisions, and the amount of heat transferred can be calculated using mass, specific heat, and temperature change, where specific heat measures how much energy is needed to change a substance's temperature by 1 degree Celsius. And now for the key moments. Throughout this multi-day lesson, you'll be making a key ideas chart. I made this example so that you can see what a finished product could look like. On the next few slides, you'll see when these ideas get added to this chart. So for the key moments in parts 5 through 7, actually we have to look back to part 4 to start. The students collect the data from their lab setup and record the data in their class Google Sheet. Then in part 5, you'll lead the building understandings discussion to guide the students to examine the data and look for patterns and trends. And this is where you'll be making your key ideas chart. So for key idea 1, you'll add that the temperature of cold initial is less than the temperature final is less than the temperature of the warm initial. And then for key idea 2, you'll have delta TA increase if mass of A decrease or mass of B increased. You'll add that to the paper along with the statement, the mass and temperature of each sample affect where the final temperature stabilizes. Now for the key moments in part 7 and 8. In part 7, we show students how to graph the data from one trial. And so then we will help the students calculate the areas. In part 8, the second building understandings discussion is intended to support students in figuring out that the areas represent energy and that energy is conserved as it's transferred. So then we'll add key number 3, that energy is conserved, to our chart. It flows between objects, but it's not created or destroyed. In parts 10 and 11, this is where we will find the simulation. So part 10, you can let them know that they can be creative and they don't need to follow a procedure yet. The goal of that initial investigation is to get a sense for how the simulation works and start to notice and wonder about what they see with the energy doing in the system. In part 11, the students will share their observations from their initial investigation, and after discussion, then you will add to your chart key idea number 4, that conduction is the transfer of energy through the direct contact of particles. And then you're going to go back to key idea number 3, and you'll replace mass times temperature change with heat and the letter Q. Finally, the key moment in part 18. This is the final discussion where you'll allow students to establish an equation for energy transfer through conduction. You'll add key idea number 5, Q equals Cm delta T. So where do we go from here? We've got an equation to calculate heat transfer to a glacier from warm water, but we may not have the information that we need to apply this equation in the context of the Ilulissat Glacier. We realize that we do not know what affects the amount of ice melt other than incoming heat. In the next lesson, we'll plan and conduct an investigation to measure the temperature change and the mass change of the melting ice. Now here's a few tips and tricks. So in part 4, this is the liquid lab. So you need to remember to prepare the cold water and the ice cubes and the room temperature water the night before so that you can put them in the refrigerator and the freezer. And you'll need a new set of water for each class that you teach. This lab will definitely require more than the 11 minutes that are listed in the teacher's edition. So plan to do it on a block day if you can. I set up the 2 styrofoam cups and the lids and the digital scales and thermometers at every station. And then I had a central table where I put the 4 containers of water at the beginning of class. An electric kettle works great for the hot water. I used colored paper signs that I laminated and put next to the different types of water. And that worked for color coding to match up with the samples that they'd used similarly in the previous lesson. You'll need to make a copy of the provided Google Sheet for each class. The students will need to add their group's data to the same Google Sheet, so I share mine through the Google Classroom. In part 7, I have a wide variety of math abilities in my classroom, so I helped a little more with summarizing our investigations handout. I made sure that my students understood what the axes meant. I also gave them colored pencils so that they could shade in the warmer square red or orange and the cooler square blue. And this helped to be consistent with the spreadsheet and the source of the data. I also provided calculators to help the math section be more equitable. And the updated simulation in part 16, to make things easy, I let the students come to a consensus about they would like to keep constant. My students chose to have the starting temperature for object A, mass of object A, and the starting temperature for object B to all be the same. They decided only to change the mass of object B. By coming to a consensus ahead of time, my students were very focused when it came to to time to collect the data and enter it into the class spreadsheet. And again, remember, you'll need a new Google Sheet for every class. It's okay for the classes to choose different things that they want to vary. In fact, that could be really interesting so that you could share the other classes' data table with all of your classes the next day. At the end of part 18, after the building ideas discussion, you'll help your students to co-construct the definitions for equilibrium, conduction, heat, and specific heat. For poster management, you'll want to have a couple of anchor charts to help you from the previous units. There's the investigation anchor chart that's from lesson 3, and then the rules for energy transfer models from lesson 2. And of course, you'll be creating the key ideas chart throughout this lesson that you can append to the rules for energy transfer chart. So to recap, in this lesson, the students investigated energy transfers between warm and cool water. They mathematically modeled their results using graphs, and they provided evidence to show that energy is conserved. They also will conduct an investigation with an online simulation that shows heat transfer between objects at the particle level, and use the simulation to help develop mathematical models of energy transfer through conduction. Through this lesson, they now understand that conservation of energy, equilibrium, conduction, and specific heat. Up next is lesson 11, where the students will plan and conduct an investigation to measure how heat and mass are related. We will consider how our results help us to address glacier melt and sea level rise. Good luck and have fun.